Thank you, everyone, for joining today. We're excited to walk you through what's new in Tonic Textual. Over the last several months, we've been focused on one core theme, and that is how do we help organizations not just protect sensitive text, but truly operationalize it for AI? So today we will show you how Textual is evolving from a de-identification engine into a full workflow platform for discovering, governing, and activating unstructured data. We're going to do our best to keep our eye on the chat. We want this to be as interactive as possible. So please, feel free to drop questions into the chat. We do have a dedicated Q&A at the end. But if it's timely and relevant, we'll try and address it up front. But in addition to that, just a very, very quick outline of what we're going to cover. I'm going to start with a brief overview of Tonic Textual for anyone who's newer to the platform. Then we're going to walk through three major updates that include the Unstructured Data Catalog, Guided Redaction, and custom entity types. For each one, I'm going to more or less frame what this new capability is at a high level, and then I'll actually hand it to Adam to show you the actual UI and how it works in practice. And for those of you who don't know me, my name is Whit Moses. I am a senior product marketing manager here at Tonic, and I focus exclusively on go-to-market for Tonic Textual. Hopefully, you know that that is our solution specifically focused on working with and preparing unstructured text for AI development and other workflows. If you're not familiar, that's okay because I've got a few slides coming up that are just for you. Adam, before we dig into that, want to tell them about yourself?
Sure. My name's Adam. I'm one of Tonic's co-founders, and I'm also our head of engineering. And I spend a majority of my time, or really all my time, working on Tonic Textual, which is what we're going to talk about today. And it's one of Tonic's three product offerings.
Let's start with a quick reminder of why we built Textual and what teams are currently using it to do. As we've alluded to and said explicitly, Textual is a de-identification platform designed to assure compliance while unlocking sensitive data for AI. Most organizations today are sitting on massive volumes of free text data. This can be clinical notes, documents, transcripts, emails that all contain enormous value. But for many organizations, especially those that are governed by regulatory compliance, that data is often unusable until it's properly protected, understood. And what makes Textual different is that we're not just masking text. We protect what we call sensitive entities within text with proprietary multilingual models. And then we allow organizations to either redact or synthesize those entities, which preserves utility while protecting privacy. And one of the biggest trade-offs in privacy tooling is protection versus utility. So often folks can redact too aggressively, which will destroy context, or they don't redact enough, which can introduce risk. Textual allows you to mix and match redaction and synthesis at the entity level. This means that you can remove certain data entirely while replacing other data with synthetic values, preserving structure and meaning. This is especially critical for AI training. And with that foundation in place, let's talk about what's new. So in speaking with customers, we saw three major challenges emerging. Number one, teams don't know what unstructured data they have and they're sitting on. They have volumes of files that are sitting in a backlog somewhere that may potentially have value for AI development or other use cases, but they know that it contains sensitive text, and for whatever reason, it's just sitting off in limbo. Number two, privacy workflows are manual, inconsistent, and time-consuming. And number three, off-the-shelf models are unable to understand domain-specific language. So these are three problems that we have solved directly for in new capabilities within Textual, and we have built features to address each one. So let's start with the Unstructured Data Catalog. As I've said before, most organizations are sitting on thousands, sometimes millions of documents without truly knowing what's inside of them. The Unstructured Data Catalog gives teams centralized visibility into unstructured text across documents, notes, transcripts, and files. You can search and filter not just by name or metadata, but by content, context, and detected entities. So this turns unknown text backlogs into a discoverable system of record. Specifically for AI teams, this means identifying high-value data sets for model development. For compliance teams, it can also mean surfacing privacy risk before data moves downstream. And to make all of this more concrete, I'm going to pass the screen share to Adam to show you how this actually works within the product.
All right, wonderful. Thank you, Whit. All right, let's start. I think Whit, you'll need to stop sharing momentarily. Oh, there we go. Read my mind. All righty. So I'll give a quick blurb about textual in general, and then I'll hop right into what Whit just discussed. So here I am on the textual homepage after you've logged in. Anyone's welcome to go and create their own account. You can do so at textual.tonic.ai. You create your account for free, and then you get 100,000 words to play with before you have to, kind of cough up some cash and start paying. Of course, for our enterprise customers, many of them do use our cloud, but you can also deploy our solution in your own environments if needed, run it air-gapped, and ensure that none of your data leaves your servers. And that experience is identical to the cloud experience, which I'm showing here. Okay, so let's go straight to the new cataloging features that we have. You'll find them under data sets. Data sets are essentially collections of files that you're either analyzing or you're synthesizing and redacting. Okay, so historically, data sets have really only been used for generating redacted or synthetic versions of files. I can upload a PDF or a text file or a Word document or an image. We can identify the sensitive text within the file, then replace it with synthetic values so that you get a new file which looks and feels real. Take an invoice, create a synthetic one, take a medical chart, create a synthetic one, etc. The data sets now, though, we're adding this new functionality where you can also begin doing analysis. And the first step on that journey is adding this catalog. And the catalog is going to be added to and improved over time. And I'll talk about that briefly as well. So we can go to the catalog here. It's under this entities analysis section. The catalog itself, actually, you know what? Let me talk about the files really quick. In this data set, in this collection of files, I've uploaded 100 medical discharge notes. These are the notes that a doctor takes as a patient is being discharged from the hospital. Of course, what we're going to go over today, these are all fully synthetic notes. We're not going to use real PHI in giving a demo. So these notes have been synthesized by us, but they look very real. And for example, if I were to click on one of the notes, you can see that our entity taggers are going in and they're tagging all of the relevant pieces of information. And by default, everything's being redacted, but I can easily synthesize it so that I get a new medical note which looks real, but it's entirely fake. But by default, everything gets redacted. Okay, but from the entity catalog point of view, that actually doesn't matter too much. I just wanted to kind of give you an idea of what types of files we're dealing with. So let's go to the catalog itself. In the catalog, you can begin kind of listing and enumerating all of the interesting entities found, grouped by the files that they're in. You could filter to specific entity types. You can filter down to one or more specific files, or you can actually just search for entities. So for example, my name's Adam. Let's see if there's any Adam in the documents. There's an Adams. It looks like Adams appears often tagged as the last name. And in all of these files, and he actually comes up across many of the files. Elijah Adams, he comes across many of these files. He's clearly a doctor, and you can see that in the short little context snippet that we provide. There's an Elijah Adams, there's an Abigail Adams. So actually, there's multiple people named Adams. So we could filter down further to narrow down to just the specific entity that we care about. So that's the first thing that we've added. The next thing that we've added on top of this catalog is a way to kind of view at a high level what types of entities we're finding in these documents. So for example, the thing that we found the most of were numeric values, which is not a big surprise. Numeric values are kind of like a catch-all for any type of numerical entity that we can find in text. These are things that are typically not super useful for analysis because they're so vague. But when we can identify a numeric value as something more specific, like a phone number or an SSN or a patient ID, something like this, then we'll tag it as that as well. So for example, let's go to family name. And then you can get an idea of by file, where are we seeing these counts? And you can understand better in your data set or in your collection of files what types of entities we're seeing. Okay, so that's the first new feature. Whit, I'll hand it back to you, and I'll start prepping the next demo. Oh, and wait, I'm sorry. I wanted to speak briefly about where we're going with these new features. So this will all be the topic of a future webinar. But where we're going to go with our new entity analysis and cataloging features is we're actually adding the ability to do full text search in your documents. So not only can you filter down to specific entities by text, but you can also search for really whatever you want across large numbers of files. Typically for the purposes of analysis or for doing further synthesis or redaction. So that's the first thing. The second thing, and this is, I maybe I'll regret saying this because it's not by any means a guarantee that we're going to do it. But beyond that, what we're looking into are some natural language features that allow for further analysis of large amounts of unstructured data via natural language. For example, let's say it's a legal data set, right? Going in and asking, hey, in all of these legal documents, where can I find contractual terms similar to the below? Or if it's a medical data set, give me every discharge note that references, white men over 40 with diabetes. So, being able to do some, much more sophisticated filtering and analysis and charting. So that's where, we'd like to take it eventually as well. All right, Whit, back to you.
Yeah, awesome. No, it's really exciting to hear about the future of the data catalog because I do think that there's going to be a lot of utility there beyond what we've already built. And thank you for adding that because I realized I had been talking on mute to myself for a couple of seconds, so you were able to fill the silence. But
I
let's take,
saved you.
yeah, you saved us all. But let's take a left turn here and talk about a slightly different use case. We built guided redaction for teams that have high volumes of documents, regular workflows that are focused on redaction, whether this is to feed documents downstream for something like AI model development, or more often data syndication. You have other teams below you or externally that need to have access to documents that contain sensitive information. And the stakes are too high to simply allow that process to be fully automated. So we've baked in what we call a human in the loop workflow to ensure that not only is this accelerated through the use of AI and happens very quickly, but there is that human layer to validate and ensure that only only the most appropriate information is moving downstream. So simply put, guided redaction turns complex privacy workflows into a repeatable, audible process. And this is done through, like I said, human in the loop precision that's accelerated through AI. There are built-in guardrails to reduce inconsistent policy application and full audit trails to understand document level activity. So this is ultimately about defensibility. If you're audited, you can show exactly what was redacted, why, and by whom. And for teams doing data syndication or research sharing, this dramatically improves the speed and confidence at which you're able to share documents downstream and externally. So that's guided redaction at a high level. Adam, can you show us how that workflow actually looks? And you're on mute now.
Uh, Nice.
It
All right.
happens to the best of us.
Favor returned. And before I jump into it, someone has asked a question about the last section in the chat. I've already answered it, but I'm going to repeat the question and answer now for everybody. Nick asks, is there an API we can call in Textual for dynamic masking and synthesis? The answer is yes. It works for both blobs of text that you send via API call, as well as for files. If you're dealing with PDFs, documents, images, things of this nature, you can do both. We offer a REST API and an equivalent Swagger or Open API specification doc. We also have an open source Python SDK that you can call into as well for doing that type of like on the fly dynamic masking. It's really, we've done webinars on that in the past. It's actually how we started this product. The product initially was essentially a set of like state-of-the-art NER models for identifying sensitive information, and then a set of, again, state-of-the-art synthesis models for then synthesizing very realistic placeholders. So really, Nick, that's kind of hitting at like our core functionality. I put my email into the chat, adam@tonic.ai. Shoot me an email if you have questions about it. And then I can drop more information as well. Also, if you just go to textual.tonic.ai, create an account, you'll very quickly see how to do all of this, and it's mostly self-explanatory, but I can definitely provide some pointers. So feel free to reach out, please. All right, let's hop to guided redaction now. And thanks for the question. And folks, please feel free to ask questions as they come in, and we can do the Q&A at the end. All right, share. All right, so I'm back in Textual. I'm not going to give a spiel about Textual this time. I'll just hop into the feature itself. This is Guided Redaction. You start off by going to Guided Redaction. You can create a project. In this case, I've created a project called tax forms. So we're moving beyond medical, and we're going to do some tax forms now. Before you get started, typically an administrator for your organization, whether you're in cloud or self-hosting it, would do some initial setup. So for example, they would kind of define the different statuses that one takes when redacting files. And then they would also define a set of reference codes. These are essentially the entities that we're interested in redacting in these files. I've gone ahead and done all that. I didn't want to get too into the weeds, but I want it to be known that this experience here that we're providing is essentially a human in the loop AI redaction system where like the AI will typically do a very, very good job. In fact, oftentimes it won't make mistakes, but you still need human sign off. Like a very typical example of this would be if you work, for example, in the government and you handle Freedom of Information Act requests. You know, a reporter requests documents from the government. Some of these documents are very sensitive. So you have to have a human go in, you know, that old school type of redaction, black highlighter. You know, this, for those paying attention, it's been in the news a bit recently. So this is how it works. And it's a very like this flow here is meant to kind of like really adapt to the organization and their specific workflows. So a lot of this is very customizable. I'm not really going to get too into those details right now, but you know we have this working with very large organizations, and you know it adapts well to their needs. So in this project called tax forms, I've only uploaded one file, and we're going to start processing it. So let's put it to in progress so folks know what I'm doing. I can also then go and share this project with others in my organization and give them the custom permissions levels or built-in permission levels so they can work with me or they can review or they can approve. Lots of different supported workflows here. But let's actually get into the file because that's probably the most interesting part. So this is a tax form. It's a 1040 form. It's your income tax form. I filled this out with some bogus information. So none of this is real, but it looks real. So our models are going to pick it up as being real. Let me zoom in a bit. I'm going to zoom in using hotkeys. In fact, most of what I do in this experience, you do via hotkey because the goal is to make the human in the loop redactor fast. You know, if previously they were redacting 10 files a day, now they're redacting 50 files a day. That's what we're going for with this experience because it's so efficient. So let me zoom in a bit. Okay, so I can see what's going on. Wherever we have this gray background, we're identifying something. So John H, detected as a given name, detected as a family name. We go over here. This is being detected as a social security number. It's looking good so far. So we're redacting as needed. Now, kind of scrolling down a little bit, I see a mistake. We didn't flag that SSN. Now, just so everyone knows, in fact, we did flag it, but ahead of time I went in and I purposefully made some errors and mistakes so that I could show you what to do when inevitably when you do encounter mistakes because, you know, no AI system is perfect. So here we have an SSN that we're missing, you know, a redaction on. So all you do is you draw your own redaction. So you can click this button right here to do it or just use the hotkey, the letter D, and I'm going to draw my box. I'm going to draw my box. I'm going to assign it a label, in this case, SSN. So it'll match the labels that we found up top for these SSNs. And that's it. I'll hit escape. I exit drawing mode, and I can move on. All right, let's go further down. All right, we're flagging money here. You know, we made the decision here that, you know, these non-zero numerical values will flag as money. If, for example, we disagreed with that, I could just go here, select all of them, and delete, or I'll delete the money tag. And now we won't redact them anymore. We still show them with this red highlight to show that, hey, we're flagging these as money entities. But if they don't have a gray background, they're not going to get redacted in the output. All right. And then you can see here there was actually a mistake that our model made. Again, this is one that I manually added for the show, but we also flagged this number right there as money, right? All of these are money values, but this is not. Okay, so what do we do about that? Well, for this guy, I would go in and I could just delete it. And now we would no longer consider that to be money. So you can kind of think of it this way. The AI gets 99% of things. You go in, you approve it, or you add your quick redactions. So now at this point, we're looking pretty good. You know, I might say that like, let's go to the review stage. So I would mark it for ready for review. perhaps this file is shared with others in your organization and you have like a two-part approval process. So one person goes in, they do their job here, they mark it ready for review. But then I've shared this project with someone else. They log in, they have the permission set to be able to review. So they would mark the file for review in progress. They would enter our review mode. In review mode, they can approve or deny each of the decisions made by both me and the AI system. And essentially, when they're done with their review mode, they can mark the file as done. It's ready for release. Okay. All right. So let's do that. I'll give you a sense of what it looks like. Well, we'll start with John. You can just do Shift Enter or click that button to mark it approved. I'll just do Shift Enter. All right. Green. It's good now. It's got a check mark. We're looking good. I can now use the up and down keys to kind of navigate. Looks good, looks good, looks good, looks good, looks good, etc. I can go through, I can approve each thing explicitly. Everything I'm doing is generating audit events. So you can go back later and see, who made what change, who approved or denied what, etc. If I wanted to speed this up a bit, I would just do this just to show that you can also do that. This file is now done, ready to be released for public consumption. And of course, you can do this for all of the files you need. When it comes time to download the document, we have many options for how the file is actually downloaded and what it looks like in its final form. But rest assured, all of this information will be redacted. And again, if you've been watching the news lately, you've seen that not all redactions are created equal. Some files that have been publicly released lately by the government have metadata that wasn't properly stripped out of the files. So some redactions are actually recoverable. Or, black boxes on text weren't placed very well, so you can actually still kind of see what letters are underneath the text, right? With our system, we go through a flattening process, prior to actually downloading the output file that strips out all metadata, so that we don't have these types of leaks that can potentially happen. So, a lot of thought goes into this to make sure that what we're doing is actually safe for consumption. All right. Thank you, Whit. Back to you.
Awesome. So we actually had a question come through in the chat that I think is very relevant to teeing up our next slide, custom entity types, which is all about custom detection. But this question comes from Udo. What types of NER models do we use? So Adam, can you explain kind of what's available off the shelf, out of the box from an NER standpoint, and then we'll get into custom entity types.
Sure. So off the shelf, we have a set of fine-tuned BERT models that we have trained over the course of the past few years with real data to ensure that our models work very well. There are open source models out there that one can use if you need to get started. You'll typically find that they don't work very well on what I'll call real data. That's data sitting behind company firewalls that isn't just like publicly available on the internet, like common crawl data. Like our data is very real that we train on, and as a result, our Roberta models are really, really like state of the art and top notch. And they have this added benefit. Like we don't use large language models for NER detection, and as a result, like our models, they're small, so they're fast, they're cheap. With using just like very small, cheap GPUs in any public cloud, you can easily process many tens of thousands of words per second. Like they're real fast and cheap to operate, and they can work really at any scale. And they're really good for those like real-time inference use cases, or if you have batch inference you need to do just on very large volumes.
Excellent. And I think that cues us up nicely to talk about custom entity types, because a consistent piece of feedback that we hear, and this is typically before a potential customer has had the chance to kick the tires with textual. But that said, we realize that there are very unique use cases out there where we often hear that off-the-shelf NER doesn't understand our internal verbiage or our specific language. And this can be due to the use of things like clinical shorthand, internal IDs, proprietary terminology, or even just niche document formats. So custom entity types allows teams to train domain-specific detectors directly within textual without needing a dedicated data science team. This is all done very seamlessly with the UI. It's essentially a no-code experience. And this dramatically improves detection accuracy compared to generic models. So you can review, refine, and deploy all within the UI. And it's worth noting here that we actually have two different approaches to entity customization, or let's say custom entity detection. With model-based custom entities being the newest, most comprehensive approach. But Adam, I think it might be helpful if you jump in and explain the difference between the two approaches that we offer.
Certainly. And in fact, I'm not going to share my screen for this. I don't think it's necessary. So we support two flavors of custom entities. The first is done via regex. So you provide a regex expression. Whenever we then scan, either text or files, we're applying this regex, search across the text to see if we find any matches. And if we do, we'll tag them as that entity type. Regex has its place in NER detection, but its place is somewhat limited. For example, let's say you're a legal firm, or you deal with large amounts of legal documents, and each contract has an ID. And that ID perhaps is like a 15-digit alphanumeric sequence. Okay, maybe the first two digits are always the same, or they're a function of the office in which it was filed, something like this. That type of entity typically can be recognized very well via regex with minimal false positives. Okay, it's well formatted. It's easy to define a regex to kind of search for it, and it's unlikely that you'll encounter other strings which match the regex but are not that ID. Okay, that's a good one. But typically with regex, either what you're looking for is not searchable or findable via regex, or it'll lead to too many false positives. So, for example, too many false positives would be maybe your ID is a 5-digit number. Well, most 5-digit numbers you encounter are not that ID, but the regex will have no way of knowing, so it's going to flag everything, a large number of false positives. An example where a regex won't find anything really is, imagine you're trying to identify names is a good example, right? There's too many names out there. You can't write a regex expression for finding names. And it would get even worse if these are names spoken, for example, in phone transcripts, where there's always these long back and forths of like, oh, hey, my name's, Adam, spelled A-D-A-M, right? Like you're not going to find this via regex. In fact, that's even tough to find via, with a model approach, even though it's something that we do. So regex has its place, but it's somewhat limited. But I would definitely use regex when you can, because it's very fast and it's very efficient, and it's very simple. All right, but we have this other experience, custom entities. Custom entities is when you really can only make a decision on whether to tag something as the entity based on the surrounding context. So for example, in this quick screenshot here, we're tagging species of bird. That's a really good example of when you really can't use a regex. There's too many birds out there. You're not going to just like whitelist it. So instead, you need like a model-based approach. And with a model-based approach, for example, if you see the word cardinal, well, okay, is that the bird or is that the baseball team, right? With a model-based approach, it'll look at the surrounding context to help determine what it is. So with a model-based approach, it's contextual. It can work with much more complex entities, and typically it will shine when regex would otherwise fail. So hopefully that kind of lays it out and makes it clear to everybody. Thanks, Whit.
That was really helpful. I know we're getting close to time. We might actually be there. So I want to throw this slide up really quick, and also mention that we did a recent webinar specifically on the former approach to custom detection that Adam mentioned. We did that about a month ago. If you go to tonic.ai, select resources and webinars, you can find a deeper look, and we actually do a full demo of the new experience there. But for the sake of time, we're just giving an overview today. And I did see one quick last question come in. Apologies if I butcher your name, but Dionysos asks, what about handwritten data, i.e. scanned forms that have been filled in by hand? Do you support such use cases? And if yes, what languages are or can be supported?
Sure. So yes, we do support that. Obviously, the more cleanly written the handwriting is, the easier it is for us to work with. I'd say in general, if it can be read by a human, typically our system should be able to read it as well. Now, in terms of what languages, so primarily we support English, but we have support for other languages as well. Typically, our models will work best in Western European languages. So, and then typically, as a rule of thumb, this is not always true, but the further east you move, typically our model performance begins to degrade. With that being said, we can always fine tune our models on specific languages as needed. So, for example, if you are curious in Greek, we support Greek. If the models though are not working as well as needed, we are always able to relatively quickly add additional fine-tuned training data in that specific language to kind of bump up the scores on the entities that you care about. And that's something that we can normally do very quickly. So if that's of interest to you, just reach out.
Awesome. Great question. Really appreciate all of the participation and live Q&A that came in. Glad that we have your attention. And like I said before, we have a link here to our product page where you can access a free trial of Tonic Textual and also request a conversation with the team if there's anything that we've talked about today that you want to take a closer look at. And feel free to shoot us a note at hello@tonic.ai. If email is your preferred channel, we're there as well. But it was a pleasure connecting with you all today, and hope to be in touch soon and keep an eye out for future webinars.
Wonderful. Thanks, everybody.